Welcome back to the SimTraffic channel. Today we'll be covering traffic metering principles as they apply to SimTraffic, VATSIM, and VATUSA. It's important to note that this information is for flight simulation use only and should not be applied to real-world air traffic control or commercial flight scenarios. Let's start with a quick overview of what SimTraffic does. Our main goal is to provide a traffic management tool set for use by VATSIM controllers to assist with metering and flow control. We want to lessen circumstances where controllers feel overwhelmed by traffic and help add realism and certainty to pilots when they receive a ground delay. But SimTraffic won't fix everything. As a traffic manager and controller, you still have to exercise good judgment and lean on your experience to get the job done. It's also important to note that SimTraffic does not schedule aircraft to the second. That is not realistic, and it isn't the goal of flow management. Instead, we're trying to ensure that air traffic services and airspace do not get overwhelmed by traffic. This is a distinctly different job than to-the-minute airspace or landing reservations. Before we learn about SimTraffic, let's cover a few important notes. First, on VATSIM, airlines aren't allocated slots like they are in the real world, so we're lacking the purpose-built method of ensuring that major airports don't get overwhelmed. Weather between different sims and even pilots using the same sim are often different. Finally, pilots don't always give us an accurate takeoff time when they file a flight plan, so it can be difficult to forecast future demand. Because of these factors, traffic management on VATSIM is a dynamic environment. Okay, enough said, let's learn about the system. I've provided some definitions that we're going to use throughout this discussion. I'm not going to read through them, but they're here for your reference. Let's talk about metering. When you set the AAR on the configuration page for your airfield, SimTraffic uses this number as the baseline for all metering calculations to your airfield. SimTraffic Scheduler will allow slots to be assigned until projected arrivals will exceed the AAR. Slots are assigned in bins, which we will talk about in a minute. Aircraft should depart plus or minus 5 minutes of their assigned slot. It's important to note that AAR is a ratio of aircraft arrivals per hour, not per minute. An AAR of 90 arrivals per hour is mathematically the same as 1.5 per minute, but that is not an accurate description of how metering works. Instead, AAR is expressed as the number of arrivals per 10 minutes, so divide your hourly AAR by 6. You enter your AAR as an hourly rate on the configuration page as a matter of convenience, and SimTraffic does the math internally to make this a 10-minute rate. Scheduling of aircraft is arranged into 10-minute rolling bins with a new bin starting each minute. As long as SimTraffic does not exceed the 10-minute AAR within this rolling bin structure, then the hourly AAR is maintained. If the 10-minute AAR is 10 arrivals, this means that 10 aircraft could share the exact same slot. But wait, how could we allow 10 aircraft to share the same metering fix time? It's important to understand that we're trying to balance for capacity. This is a dynamic environment and it requires some flexibility. If 10 aircraft share the same slot, they will not all take off at the same time. Remember, there's a plus or minus 5-minute window. Also, the flight environments will differ, and there are many human factors to consider. If for some reason all flights are still perfectly on time, the space that SimTraffic builds in the 10-minute rate will allow terminal controllers the flexibility to sequence via speed, vectors, holding, etc. Again, this is about ensuring that the 10-minute rate is maintained, not a 1-minute rate. The load graph and the AADC display the sliding 10-minute bin. In order to establish a rate, you are looking 5 minutes into the past and 5 minutes into the future on these tools. Let's talk about these bins some more. Assuming that our AAR translates into 10 arrivals per 10-minute bin, if we fill up a 10-minute bin with 10 arrivals in the first minute, then we can't schedule any aircraft until 10 minutes later when that bin rolls over. If aircraft are spaced out 1 per minute over 10 minutes, that means that we'd have an opening as soon as the bin rolls to the next minute. It's confusing, but don't worry, we've got a visual depiction coming up next. This chart depicts an AAR of 96, or 16 arrivals per 10-minute period. Watch as the bin rolls forward in time, and the rate of 16 arrivals per 10-minute period is maintained. The 10-minute bin is shown in pink, with the 10-minute rate highlighted in pink at the bottom. Each green block shown above a time represents 1 arrival. For reference, the estimated 1-minute rate of 1.6 arrivals is shown with a red dashed line. Here's an example of the bins and the load graph. You can see in the spreadsheet on the right that at the 8-minute mark, the AAR of 16 is exceeded by 1. At the corresponding time in the load graph, the rate in green exceeds the max AAR shown in red. Because traffic to this airfield is metered, the purple line shows that SimTraffic Scheduler dealt with this conflict by spreading the exceedance traffic out over the next minute in the available slot time. In the spreadsheet on the right, this is reflected by bringing the exceedance forward into the next available bin. Now let's move on to the TGUI, also known as the ladder. This tool is based on a real-world tool for managing flow. ETAs are displayed on the left, and STAs are displayed on the right. The tape in the middle is the time reference, and the bottom is the reference fix. Everything on the ladder is meaningful. Aircraft ETAs on the left are displayed in green text. Aircraft in the STA column on the right are displayed in yellow to indicate an unfrozen STA, and blue to indicate a frozen STA. Frozen STAs do not change as they were assigned as a slot or are too close to the metering fix. Unfrozen STAs freeze when the aircraft enters the outer metering arc for an airfield. The symbols next to a call sign indicate the wake turbulence class. Here's a representation of the ladder next to a plan view. Let's walk through the aircraft. United 73 is 4 minutes early with a frozen STA. JetBlue 517 is a large aircraft that is 3 minutes late, also with a frozen STA. Delta 456 is an on-time 757 outside of the metering arc but with a frozen STA, which means that it departed with a slot time. Finally, American 1523 is an on-time heavy with an unfrozen STA outside of the metering arc. That was a lot of information, but if you're interested in learning more, here are some great resources. These links are in the video description. That's all for now. Thanks for watching.